I'm going to teach you how to draw transverse waves on a graph when certain variables are given to you. The graphs will always be given to you and the axes will be filled out. And let's look at the graph real quick before we get started. I'm going to look at my x-axis here, and if you notice, as with any good graph, it has units. However, it's unusual because I see 2 units there, and normally on an x-axis we only see 1. That simply means that the numbers on the x-axis represent both distance for centimeters and time for seconds. So it does double duty. On my y-axis, my unit is simply centimeters, so it's just a distance measurement. Another thing that's different in physical science, normally we just work with positive numbers, but when drawing waves, we work with both the positive and the negative numbers. And we've learned that the waves have a rest at 0, and here's our rest line, and then we've got the positive numbers above and the negative numbers below. Okay, so now where do we start when we're drawing our waves? We look at the problem. The problem says, draw a transverse wave with an amplitude of 10 centimeters and a wavelength of 2 centimeters. Now let's remember what the words amplitude and wavelength mean. Amplitude means how big is the wave, or how tall is the crest. So that would be the numbers on the y-axis. The wavelength is what distance does my wave cover? What is the length of my wave? So those will be the numbers on the x-axis, and that's where we're going to start. We always start with the wavelength number. And in this case, my wavelength number is 2 centimeters. So I'm simply going to put a dot on my rest line, or my 0 line, at 2 centimeters. That's the length of my entire wave. So the positive part of my wave and the negative part of my wave have to fit between the starting point and the ending point. Now fortunately, waves are symmetrical, so it makes it a little easy when we're trying to graph them. If the length of my wave is 2 centimeters, then the halfway point would be 1 centimeter, so we're going to draw a dot there. That's the halfway point of my wave. And when we graph a wave, we always start at the rest line and we go upward. And it's symmetrical. All waves are symmetrical. And we want to first draw where our crest would be. If you look at the problem, it tells us the amplitude is 10 centimeters. So that's how high up the crest is going to go. So if I look at my y-axis, here's 10 centimeters, and I'm going to draw a dot halfway between the start and the midpoint. And then I'm going to connect my dots so far. I find if you connect your dots as you go, it's going to make it easier than seeing a bunch of dots on a graph at the end. So here I have my crest, but we know that waves don't only go positive, they go negative as well. So now I have to draw the point where my trough would be. It's 10 centimeters on the negative end, and again it's halfway between the dots on the rest line. So it's very nice and symmetrical, and that's one wave. But you're not done. When given a graph like this, you need to draw waves all the way to the end of the graph, to the point where you can fit in your last complete wave. So we're going to keep going. So there's my one wave. I'm going to draw my next one, and the wavelength is 2 centimeters. So my starting point is at 2, my ending point is at 4. So now I'm going to complete the wave. My halfway point between them would be here, so I put a dot on the rest. And now we're going to draw the crest up to 10 centimeters, halfway between these two, connect my dots, and then draw my trough. And I'll continue. 2 more centimeters for my next wave. I'm going to look at my halfway point. Now notice I'm going to be going up again to 10 centimeters. Draw my crest and my trough. 2 more centimeters is my next wave. I need my halfway point, so I put a dot there. Again, drawing my crest, I go up to 10 centimeters. Drawing my trough, down 10 centimeters, and complete the wave. Another wave, 2 more centimeters over, which would be 10. I need the halfway point. I'm going to draw my crest and my trough. Now it looks like I can fit in one more wave. So my wavelength is 2 centimeters. Mark my halfway point. Go up. And you're going to go down. And now the graph is complete. However, the problem isn't complete because it asks you a question down here. It says, what is the frequency of the wave? You've learned 2 different ways to calculate frequency, and we're going to go over both ways when we solve the problem. And I'm going to show you that no matter which equation you use, you're going to get the same number. All right, the first way, and I think the easiest way after you've drawn all these all these waves, is frequency equals number of waves over the total time it took for those waves. So now we have to count the waves. Counting waves is very simple. You're going to start at a starting point, and you're going to go up, and down, and stop. Okay? You're going to just trace one complete wave. I like to do this with my finger on the paper so that I don't lose count. So that's one wave. Up, down, stop. That's 2. Up, down, stop. That's 3. Up, down, stop. That's 4. 5, and 6. I have 6 total waves here. So that's the total number of waves that I have. And then I write down how long did it take me to graph 6 waves. And my 6th wave ended over here, and I go down, and I look at my x-axis, and I see it took 12 seconds. So I have 6 waves in 12 seconds. So all I'm going to do is I'm going to divide that out. 6 divided by 12 is 0.5. And my frequency is 0.5. And if you remember, the unit for frequency is hertz. Okay, let's calculate it another way. And I'll show you I get the same answer. Frequency also equals 1 over t. T stands for period, and if you remember what period is, it's the time it takes for one wave. So in this case, I would have to figure out how long did it take for one wave to be completed. So I'm going to start here, and I'm going to draw one wave. I'm going to go down, and I'm going to look at the time it took for that one wave. So it's 1 over 2 seconds. And again, I'm going to get the same answer. So however you do it is fine. Just make sure that whichever equation you use, you've got the correct information that you input. All right, let's do one more practice. All right, this one says, draw a transverse wave with an amplitude of 5 centimeters and a wavelength of 10 centimeters. So I've got my graph here. And remember, the very first thing I'm going to look at is the wavelength number. That's the first dot you put on the graph. So if you see, this one is 10 centimeters, so I'm going to go to my rest line or my zero line and put a dot at 10 centimeters. That's the length of one complete wave. So now I need to mark the midway point. It should be right here. And remember, my graphs always go in the upward direction first, but I have to look how high is my wave going to go. And I look at my problem. My amplitude is 5 centimeters, which is all the way at the top of this graph. And I'm going to go and put it dot halfway between them, and then connect the dots. And I'm going to do the same thing on the negative end because the wave has both a crest and a trough. All right, so that's one wave. And remember what I said, you've got to complete the graph as far as you can go. So my next wave would be another 10 centimeters. So I'd put my dot for my complete wave. I will look at my midway point, cut it in half, draw my crest, cut it in half, and draw my trough. And notice again, it's very symmetrical. They look exactly the same. I think I can fit one more in, so 10 more centimeters. Going to cut it in half for my midway point, draw my crest, and draw my trough. That one was a little easier because I didn't have to draw as many waves, and it just depends on the information given. But again, I have to calculate what the frequency is. So let's do both ways, like I did on the first problem. Frequency is number of waves over total time. So I'm going to count my waves. I'm going to start here. Remember, a wave has a crest and a trough. So that's one wave. That's two waves. And that's three waves. So I have a total of 3 waves. How long did it take me? If I look at the end of my third wave, I'm going to go down on my graph, look at how many seconds it took. It took 30 seconds. So my answer would be 0.1, and my unit for frequency is always hertz. All right, the other way we learned is frequency equals 1 over period. T stands for period. And it's really the same thing because it's the time it took for one wave. Instead of total number of waves in total time, it's one wave and how long did it take. So if I counted out one wave here, how long did that take? It took me 10 seconds. And I get the same number. So I don't care which equation that you use because they both will give you the same answer. The more practice you get, the easier it's going to be for you. Please replay this as many times as you need help until it clicks. Once it clicks, then you should be fine with the graphing of the waves.